thumbs up or a wave just to let me know that you've got it, and then we can proceed from there. Looks like I've got some hand raises, so I'm assuming that it's working. So I'm going to turn it over to John McManus now, who's going to introduce our speakers for the afternoon.
Okay, thanks, John. We are very fortunate to have two speakers from Ohio EPA who definitely know something about developing an approvable stormwater pollution prevention plan. We have Justin Reinhardt, whom many of you know. Justin is an engineer with Ohio EPA Division of Surface Water, where his role is to provide engineering assistance to the stormwater program. This includes developing and maintaining Ohio's Stormwater Manual, the Rainwater and Land Development Manual, as well as providing technical help to Ohio EPA staff and help to us, to the regulated community, as well as consultants and developers with navigating Ohio's construction general permit. Justin has 20 years of experience designing both agricultural and urban conservation practices while at ODNR and the Ohio Department of Ag before coming to Ohio EPA. He has a BS in civil engineering from Ohio State and is a registered professional engineer in Ohio. We're also thankful to have Wesley Sluga. Wes is an engineer in training with Ohio EPA's Division of Surface Water's Stormwater Program. His work involves providing technical assistance and engineering guidance for consultants, developers, EPA staff, and the community regarding the Construction General Permit and the Rainwater and Land Development Manual. Wes has a BS in Environmental Engineering from Cornell University, and he is pursuing a master's at Ohio State. Justin and Wes, thanks very much for helping us with this webinar, and Justin, I'll turn it over to you.
Okay, thank you, John and Sarah. I will move to our presentation. Okay. And everybody can hear me and see me okay, I'm assuming. Great. Well, thank you again to Save Local Waters for hosting us today. It's unfortunate that we weren't able to proceed with the in-person workshop. I very much enjoy seeing and talking with folks in person, and especially on a regional basis, but I suppose the advantage here is that today we get to offer this statewide, and I see we had many partners register across the state. So thank you for accommodating the current times, and we'll see how this goes. Also for setting the bar low, as our goal today will be to not have any glitches. Thank you, John. I think that gets Wes and I off to a good start. Anything we do and say from here on out is hopefully just icing on the cake. This is the first one I've done of these webinars since COVID-19, so hopefully it does go well. But if there's questions or problems, please let me know. John, I believe you mentioned also that this was being recorded and may be available in the future. So here's Wes and I and our contact information, and you probably will more recognize us as this, or at least the foreseeable future, as we are currently working telecommuting as many of you are. So welcome from my basement. So to talk about an effective and approvable SWIP and developing a SWIP, we're going to sort of split that discussion up, and I'll start off with maybe some bigger picture overriding thoughts, and Wesley will follow up with some details from his perspective in the work he's doing, evaluating and reviewing a number of SWIPs recently, and some of the trends and issues, and I don't know if I want to use the word issues, but comments that he's made frequently and things he's saying, and we'll hopefully tie that all together here. I want to also lead off by something that I'm often forget to do, but that is recognize that although we throw about a lot of these terms and jargons, and especially acronyms, on an almost hourly basis, oftentimes on these webinars we have newer employees and that may not be familiar with them. So I wanted to just kind of throw this up really quickly and run through our more common terms and abbreviations that we'll use today, so you'll have them. Okay, so to start us off, thinking about a SWIP and developing a SWIP and what is an effective SWIP, and ultimately approvable is just the same, an effective SWIP. I wanted to start by taking a step back and looking at how are we going to talk about that in an hour, hour and a half, more or less, and a simple webinar when we have really a SWIP document that's meant to be a very tailored, custom built tool that is site specific for the project, and yet at the same time is something that is really incredibly diverse. Just a few statistics I pulled out the other day, so these are current, that we have almost 6,000 actively covered sites under the general permit, construction general permit right now. Now, some of those may be needing to be terminated, but that gives you an idea of the amount of work. Much of that is covered under 623 MS4s in the state of Ohio. Now, those are pared down to just under 300 total permits, as many of those local MS4s are relatively small and grouped together. But you still have almost 300 different reviewing and regulating entities out there that are discharging through a separate sewer system. We've got sites ranging from, believe it or not, we have a few under 1 acre in size that from time to time come to us for various reasons, including some communities that regulate to less than 1 acre, although the threshold in the statewide permit is 1, up to currently 250 acres in size as one contiguous site. So we're talking vast differences, as well as the amount of work that would be deemed a construction activity. Many of you work in a typical setting of residential, commercial, retail, institutional type of industrial construction, roadway, municipal construction, but we have so many other activities, earth disturbing activities out there that end up being covered in various ways under the permit. Couple that with the fact that we have many SWIP preparers submitting SWIPs in and across the state, all with different ways of doing that work, different for various reasons, different templates, different company standard operating procedures that are utilized in larger firms, different software that's available to them that they utilize to do their work, all being pushed into a SWIP that may fit any of these possible scenarios. So I guess that's a long-winded way of saying it's probably impossible for Wes and I to very simply in an hour and a half explain exactly what goes into a SWIP when there could be so many different things, but we'll give our best shot. So from the broad, I'm going to narrow way down in, and rather than go through line by line, all the different requirements listed out in 70-something pages of the construction general permit, I really want to focus in on one quote, one direct quote, one line of text, and that is, as a reference here, page 11, the SWIP shall describe and ensure the implementation of best management practices. Now that struck me as being awfully heavy when I started to think about ensure the implementation of best management practices. It's quite a responsibility that we're stating a SWIP is to do, and I try to come up with an analogy to this, and for some reason maybe this is not relevant to some of the audience, but I thought back to Joe Namath and Super Bowl II of all things, and that was the original guaranteed victory. And it's like, whoa, I mean, can we do that? Are we asking that we guarantee victory through a SWIP? And I don't know if that's necessarily the case, that we're saying there shall not be problems, but ultimately what we're saying, I think, is the SWIP is a complete game plan war plan. Certainly, Broadway Joe wouldn't have said that famous guarantee if he hadn't been confident that they'd addressed all the different elements of the game and really felt bold and maybe even knew something that the others didn't about their game plan. And really that's what that's what the SWIP is. It should be confident that it's addressed the majority of problems and issues that may or will likely arise on the site, and give the contractor confidence that he can complete the project without enforcement violations or pollution problems, to be even bigger picture thinking. So with that said, that leads me to look at the whole SWIP development process, and I pulled this out of the US EPA guidance document, and I only want to show this graphic because as they set their guidance up chapter by chapter, they go through like any of us would and itemize out the different components through the chapters, and they have two separate sections of development, which is what we're talking about, leading into implementation. And then you see it's this typical process-oriented flow chart back with an update and swirlies down here in chapter 8, and really emphasizing that there's this movement that's happening. It's not just a one-time type of scenario. And I think that's great. And we emphasize that a lot, that the SWIP is really a living, breathing document. It's maintained on site throughout the course of construction. It's modified, it's adjusted and adapted as such. And we recognize that those things are going to happen. Everything isn't completely predictable. But to an extent, the reality is, on most projects, from my point of view and experience, is that that process really is somewhat short-circuited, that there's very little processing through the entire development process. Word is hard to avoid, in engaging, implementing, and finalizing a SWIP. Once the SWIP is complete, construction starts. That update scenario tends to just revert back right into the implementation phase, and that's all well and good, and it's understood that it happens as part of the nature of, I think, projects today, and that essentially the original designers are often not necessarily brought in once permits are obtained, plans are signed off on, construction is green lighted. But just anecdotally, what can happen there in scenarios, not to say that it's anyone's fault, and looking at an image here where there's clearly some stabilization that's occurred and clearly a failure in a sense that we've got massive amounts of erosion going on and gulling through here. And at this point in time, contractor now is left to fixing this scenario, which more often than not is a response of bringing in more rock, more stone, and attempting to stop this unraveling, which you can see has not been very successful. And again, not to class blame or point fingers, because these things happen, but it just highlights the process that really isn't much of a process, that we really have to have things done well and done right the first time, because these scenarios happen. And not to say that we can't or should have foreseen this, but at least provide mechanisms to hopefully better address, prevent, and maybe even at times correct those type of problems. So I think, again, to keep this very first bit a little bit big picture, our mindset going into the development of the permit is oftentimes, and justifiably so, looking at the permit and saying, what in the SWIP, or what does the permit require of the SWIP? What am I required to be done? What is the minimum, and what does it say to do? And I'll do that, which is okay. I mean, that certainly gets us what is needed, but I think really to be an effective and ultimately then approvable SWIP, if we really kind of step back from that and look at our site and the conditions that could occur, and throughout that process, and determine what are the elements needed to prevent those problems or fix them if they arise. So a little bit, I know that's a little, and it's hard to do in this sense, be not too preachy, but I think it's important to recognize that just working through the what you have to do probably doesn't get us ultimately to where we want to be. Another element that is often challenging, and I think for all of us, is that, especially as an engineer, our focus tends to be on ultimately what's the bread and butter, the permanent infrastructure that's going in. That's the fun stuff. Whether your specialty is in the piping, the utilities, the pavement, the structures, the grading, balances, and all the other elements of developing a project, or something more elaborate or extravagant like airport construction or wastewater treatment plant construction. The focus is always on the permanent infrastructure and the end result and the end game, whereas the SWIP is such a different animal from the construction plans that it is often really a focus, it's really focused on the construction process and providing tools, not necessarily permanent, but temporary tools and usable tools to guide the operators through that construction process and ultimately get to that permanent infrastructure. And a lot of times what really gets weird is when we start to mesh those two things into one document. And it's not that that's not doable. I think it's just important as we go into it to make sure our mindset is that the SWIP components are really a process-oriented element, whereas much of the rest of our work is really focused on that permanent infrastructure. Of course, there's challenges to doing all of that, and that we clearly recognize. Contractors don't want to redo work or do work over again, so we have to really think about, okay, how do, if this is temporary, how is this going to fit into the whole big picture? There needs to be flexibility. We can't sit there and dictate every line item and every action step to the nth degree. There needs to be flexibility because we don't know certain elements of the project, and also certain environmental factors such as weather may come into play, other delays that might occur. So we need to build in flexibility. But that doesn't necessarily excuse us from providing instruction, because ultimately the contractors and operators are looking for instruction on how to do the things that they need to do. So how do we kind of wrap all that one into this strange, interesting animal of a SWIP? Again, ultimately, whatever we're doing as far as project goes, it's a simple process, really, and I don't want to belittle it, but I also don't want to belabor many details. It's looking at the site, looking at the project from beginning to end, and assessing the project vulnerabilities from a pollutant standpoint, heavily focused on the sediment loading side of things. And some of those common, we'll work through here in a minute, some of the those common vulnerabilities I've listed here. And then applying the proper BMPs. So those BMPs are in some cases required, and very specifically required through regulatory documents, including the construction general permit. Sometimes the site might necessitate things be done a certain way. There's also an element of BMPs that are maybe more along the lines of a tool box that can be employed as needed or as conditions arise. That's an important element of a SWIP, I believe. So if I take those two steps and really start with looking at the vulnerabilities that I mentioned, I was reviewing a study. It's probably dated. I don't remember the date on it, but it's probably 10 or 15 years old now, that looked at a small site, and the numbers are astronomical. The amount of TSS, or total suspended solids, and runoff over a small construction site based on event mean concentration were 150 times during active construction, were 150 times what they were before and after construction. I mean, and I don't know, there's probably a lot of details, and that may just be one study, but clearly shows an astronomical rise in sediment export. And really the demarcating factor there is vegetation, the clearing and establishment of vegetation, as far as what is construction, what is not construction. Those are our bookends. So it's important to recognize that you know, we need to think of these controls right from the get-go. So this top picture, I get, this is my gold star winner. I think I'll probably point to this a lot into the future, although it may not necessarily be the most commonplace. I call it the beans before basin picture, and that, or the basin before beans. I almost said that backwards, huh? The sediment basin is in before the beans have been removed from the field, and I mean, you can't really get much more upfront than that. I know the permit has language in there about when sediment basins are to be required and perimeter controls within grubbing, and you see on the bottom here, 7 days is a quick period of time. So, you know, there's some flexibility there, but as soon as that vegetation is removed, those areas become extremely vulnerable and susceptible to erosion and then sediment transport. Areas like this where you can see a little bit of that, I outlined it, a little bit of a topography there, a swale that might not even really ever almost flow in the completely wooded situation, are going to be heavy conveyors of runoff once vegetation is cleared, and then obviously especially once construction activities start and those loose soils become compacted, that water storing topsoil begins to be stripped. Another high vulnerability spot, concentrated flow. So this is one of the reasons there are a lot of the requirements in the permit are sort of, to me, a forced thought process. The contours requirement for existing and proposed contours, especially the existing. I mean, it's useful to the designers in looking at how the site is eventually going to be laid out and cuts and fills that are going to be necessary to make the most conducive layout for drainage and other reasons. But here's the scenario. If you look in the upper drawing, I excerpted here, where you can highlight, doesn't maybe show very well, but clearly these contours come down to a point and there's already even a dotted line indicating a flow path. It's a channel of some sort. And then we cross that with silt fence. Those are areas where we're going to have a lot of vulnerabilities, and sediment barriers, including silt fence, are going to be probably minimally successful in stopping that. In areas that maybe a sediment trap might be a more appropriate practice. As you can see in the picture there, just simply the force of water coming through there they've gotten a little bit of benefit from the fence post, and had to reinforce with some straw bales. But those are scenarios where understanding, you know, where water's going and then applying those BMPs is going to be critical. You know, speaking of that, concentrated flow areas, those are again a high vulnerability place where we're going to see probably a lot of erosive soil movement, as in this channel that's constructed here, and very difficult at this point to remedy. We've lost topsoil for seeding. We've got gullies now that will need to be either filled, and now we're moving water on fill. We've got a little bit better structure here in place and a rock check to attempt to now slow or stop that erosive gulling, but it's, you know, at this point it's probably too little too late. Maybe a scenario where we would have had immediate stabilization, mulching, seeding, matting as necessary, rock checks as necessary, would probably have done a real good job at preventing that gulling from happening in the first place. So those are areas of high vulnerability where we want to probably focus a lot of attention with concentrated flow areas, whether they're existing or created areas. I also require the proper BMPs. Again, here, a silt fence used as a check dam in a sense. Even under this very relatively small swale, flowing swale isn't holding any water, to use a bad pun there. And oftentimes, if we haven't specified something as a necessity to be placed or an option to be placed, you know, these are the type of tools that we're going to have to pull out of thin air, or a contractor may pull out of thin air at that point when he's told to by my counterparts more in the regulatory elements to fix something or change something, and you know, the toolbox is bare. So we don't want to leave them with the toolbox being bare. I mean, some of these scenarios aren't foreseeable, but again, we want to make sure that we address all the possible situations with the proper BMPs. And then the third scenario I mentioned is a place of high vulnerability are steeper slopes. So whether, again, natural slopes or constructed slopes, when I see the contour lines become almost the hatching of sorts, I know we've got something there that we need to pay attention to, and making sure that we're armoring this with all the tools in the toolbox that we have. Otherwise, we end up underneath my my text there, really quick erosive rills starting an erosion can be fairly severe fairly quickly if it doesn't occur. So those, those areas might be fills oftentimes along the perimeter, as in a couple of these cases shown in the pictures. They may be they may include a basin, a stormwater pond, embankment, dam, or the interior side slopes. Those are areas really craving immediate attention, immediate stabilization, proper mulching, matting, seeding, etc., and other reinforcing tools, whether it's silt fence as shown here on the top, the bottom, or other tools we're using to make sure we get that stabilized quickly. Probably the first and foremost question to ask is, do I need to clear it to begin with? When I look to the lower right, I see an area, and I don't know the history to this project, but in the background you can see the clearing starts, and at a certain point there, and I don't know what the scenario was, but my first question is, well, do we need to clear that in the first place? Can we just avoid that slope all to begin with? Would be a good question to ask. So those are three areas that I think, as we're developing a slip, that we want to make sure that we're paying very close attention to, because they're high vulnerability spots to us from an erosion standpoint. Once we remove vegetation, place soil down, erosion becomes very easy to occur, and then we get a lot of sediment transport offsite. And I like the picture on top. I showed you half of it earlier, but you can see now the other half. Timing is really everything when it comes to the SWIP. In the upper picture, you can see the area to the right was seeded presumably relatively soon after construction, and appears to be relatively stable, probably because it's along the perimeter, or maybe to the entrance of the basin, work that was done probably about the same time. But you have to the west or the left an area that was not and clearly is suffering. So again, anecdotally showing that evidence of timing is really of the essence when it comes to problem solving and prevention. Timing seasonally, oftentimes hard to predict, and somewhat contrary to thought, a lot of the erosion ends up occurring more during the summer season when things are dry, like that above picture. Yet you have the severe gullying going on because you have a period of our large, intense thunderstorms. Lots of water coming down hard, very impactful, and lots at once on now relatively disturbed soils. Versus the winter months here, where we've got a construction pause maybe that's going on, and very difficult at this point in time to do much anything. So I think key there being, we know we're coming up on the season. Do we take action in advance and preparations through temporary stabilization and in good phasing of construction, so that we don't leave areas open and exposed over those winter months when we're not going to be working and seeing that snow melt occur in all of the winter precipitation, as you can see there to the lower left, running off. And with that, the timing, I think, is, I want to lead into the schedule. And I kind of lied when I said there'd only be one quote or one excerpt from the permit. As I went through this, I found that it might be worth pulling up the exact wording there on the on the SWIP list as far as our schedule goes. But it requests an implementation schedule be included with the SWIP, which describes the sequence of the construction operations and the implementation of the BMPs that go along with those. And that's easy to do, and I think that most people are in preparing a SWIP are doing just that, are in various forms, putting together a construction schedule to the best of their abilities, understanding that there's many items here in this discussion that are either out of the SWIP designer's control or unknown at the time the SWIP is being developed, and that's certainly understandable, but it's also, I think, a manageable expectation there, in that we have to also not get too caught up into the concept of construction schedules. I know I used to do a lot of construction schedules early in my career working for a contractor, submitting those with bid packages, and I've seen some just immensely impressive schedules lining the walls of construction trailers like wallpaper. Clearly at that point in time is money, and timing is very important. But up front, those things may not be unknown or may not be dictatable. But we do know the various operations, and we can think about those in terms of what is the best sequencing of work to minimize problems on a bigger scale. We can install or employ contingencies that when various things occur, those BMPs are to be used, regardless of the exact date or month or time that they occur. We can make sure we establish the dependencies. Some of those are outlined in the permit, such as temporary seating on idle, disturbed areas. Others, we might be able to make sure that we call out and focus and highlight. Mention seasonal issues. If we see or predict work stoppages, gaps in construction, whether it be seasonal or other reasons, are there tools that are listed as to what we're going to do when those arise? And I think really, mostly I want to just mention, a good schedule ties the whole SWIP together. It's often just one little tiny component, but in my mind, because as I said a few slides ago, timing is everything, and some of the photos from before showed that BMPs ill-timed don't really work very well. So timing is maybe more important than the actual BMP and design in places. So I kind of took a stab at looking at an implementation schedule, and not that you should use this as an example or as a, oh, Justin said do this, so I'm going to do it exactly this way, but to more so to get the wheels turning on things. And of course, the first thing we said is the schedule needs to really look at different operations in the sequence of those, and realizing that at this point in time we may not be able to establish a specific time frame, but let's at least try and categorize those operations. What are the order they're going to be in? They're generally pretty basic, and lay out a little bit of expectations of what are reasonable time frames, so that we can start to see how this whole thing is going to piece together. This isn't important from a construction standpoint as so much as a building the SWIP. What are these pieces and where are they going to go? Really sort of almost the first step in building the SWIP is getting us thinking sequentially and chronologically. I added this in there as a sort of cross-reference, like how do we then build our SWIP according to this sequence or this chronology? Do we tie the actual physical components of the work that's shown in the mostly drawings, sometimes our specifications, to that exact sequence? Do we have that sort of lined up? Do we just have one or pre and post construction type of plan that's set up, which again is understandable, because that's probably from our permanency focus of what do I got now, what I might have at the end. But maybe we can work to bring in a more detailed chronology here, looking at these phases as they're probably going to occur throughout construction. And then lining up the plan, be it narrative, description of what to do, exactly when to do it, listing the BMPs that are going to be used, and then, of course, the schedule is only going to provide us the list and the timing, and then the location and all that will be indicated on our plans, but we can break that down and then even provide a contingency sort of scenario. These are the other things that might be necessary throughout this phase that may or may not be included in the plans, but are that whole toolbox I said that is provided via the SWIP. So again, I didn't get this completed in time, but I thought it was enough and worth showing at least as a concept. So that's hence my little caveat up there. Going back to then tying that to the drawing. So now we've got, these drawings that are really thinking sequentially and chronologically. Our pre-construction, again, most people are doing existing conditions, but let's take that to what's existing, what's beyond existing, to what's construction day 0, day 1, when we're implementing those initial practices and emphasizing that those go in before the rest of the work is done. So I've got my basin shown in here, and diversions to that basin, and some silt fence down to the left, and maybe a few items on here like the dotted line I added in as a drainage area to help SWIP reviewers understand what's being collected in that particular basin and identify how that matches then up with the other parts of the SWIP, such as the design of that basement and the narrative within the SWIP. I've got my table showing all the different various requirements to the basin and checking that with various tools provided to show the reviewer that all of this lines up and matches up per the design requirements and per my intended outcomes here. But then I look beyond that and say, okay, especially when I start thinking timing wise, it's like, well, I got the basin in, and most everyone is pretty up to speed on basins. But let's look at, well, what about the next steps? When the basin's constructed now, can I also then go ahead and seed those areas? I've got a slope I created by an embankment constructed to the left. I've got an area where the whole basin is in a reserve. So that work shouldn't need to be touched later through home construction. So can I get that whole area stabilized up front before a lot of the other work occurs? And those are things that maybe we can call out in a plan. We can call out those areas, as I note there, as, hey, this is a pretty vulnerable area. It's very important that we get this stabilized up front. And these are the tools, the BMPs that we have to use to do that. Swales, again, they show kind of a timing scenario, like how are these going to go in, when, are they going to be removed, when are they going to be removed throughout the process. I move to my next step. Now I've got really clearing and grading happening. I've got the rest of the site being removed and brush being removed, some mass grading probably starting. These are areas where now we can start to see water move differently. I've rough cut my roadway. I've got a culvert down at the bottom of the hill. That roadway immediately turns into basically a riverbed and concentrated flow. If I'm not careful and prepared, if my timing is not right, I might need to utilize additional tools to prevent problems from happening, like this sort of gully erosion that happened at the end of this culvert going down into the basin in a very similar scenario. I've got my storm sewers coming in next. I've got now inlets. So how am I going to protect those inlets? Add to the treatment train through fabric protection, such as shown here. Maybe I've got to put sediment traps. The grading is inadvertently acting as a sediment trap in this scenario. Maybe I utilize other tools during this phase where now I've got the help of having a sewer system direct water, but now I've got that water in runoff coming to me in a much different and much more concentrated manner. Areas below here now, how do I make this work where I had a diversion going into storm sewer and a drainage swale? Making sure we're indicating in our plan how's that all going to fit. But most importantly, I think, is once I've got that area done, I've got the sewers in, I've got a swale in place, that's going to start moving water immediately. Those areas shouldn't be subject to really probably any further construction on the actual lot site. So can we get those stabilized? Or if we're not, do we need to employ traps, again, like is almost inadvertently created here at this inlet? Can we get those areas seeded, silt fence moved, so that we're really doing a sequencing and a phased type of project? And then I moved to, eventually getting to the individual lots, and my individual lot plan is usually generalized, but I do want to call out that there may be scenarios where we need to make sure that we're very emphatic about certain things happening as individual lots get developed. And I'm using a residential site here as this example, but so this clearly wouldn't apply to a lot of other sites, but I think hopefully you kind of see the concept I'm getting at here, which is this chronological thought of developing a SWIP and then tying all these pieces together based on that chronology, not just in the plans, because the plans are very important. They're obviously what the contractors and operators are going to be focused on, but that they tie to the other components, the narratives and the design criteria and documentation. And then long-term, what do I have going on? Temporary stabilization, we've got 2 different sites. The upper one, great, everything is done. It looks awesome. We're going into winter clearly, and we've got nothing. Can we emphasize that these areas are finished and can be stabilized? And then on the bottom, you can maybe see a little bit of grass, and great, they actually did that. And, well, things happen. Of course, that became the roadway to all the next door neighbor home construction projects. And, that happens, and we can't control that, but we can at least make get a good start by not getting us to the upper situation and making sure that we get that temporary stabilization in. Post-construction, that was a heavy load of sediment control. I think when we look at the post-construction elements of the SWIP, the most important thing I want to probably hone in on is just much focus is on the peak control elements and the movement of water, but really the post-construction design is so different in that we look at the water quality volume. It is that 0.9 inches is looking at the annual average, the long-term and a complete volume of water. So you can see in those 2 charts, it's that whole knee of the curve discussion. We're collecting the vast majority of water in that 0.9 inch event. It's not correlated to an actual event. It's simply a statistical value looking long-term at how are we getting 90% of that runoff collected so that we can treat it. Because of that, a lot of misconceptions occur based on our traditional just quantity of water and outlet control thinking, that we really don't have a bigger is better scenario. If I move that 0.9 to 1 inch, I really don't collect much water, as you can see on the lower chart. So you really can't overcompensate, and it's not it doesn't become an apples to apples type of calculation. And lastly, demonstrate compliance. Wesley and I are trying to provide a lot of the tools to help with that, both through the review process and the application process or the development process to show that the designs are meeting the various criteria. 2 of the spreadsheets that we have posted on our website. Non-sediment controls, again, I don't want to mention too much about these, but I also don't want to skip over them. They're very important, and we probably, some of these, like the ones on top, can be very significant depending on the type of work going on. So that's sort of a site-by-site scenario. The bottom ones are probably controls needed on almost every site, waste disposal, for example. So are we indicating those on our plans? And Wes will probably go into more detail on some of those things he's seeing with them. I think other big picture topics and things that I've seen, one is being specific, especially in today's day and age where we've got a lot of moving pieces on a set of plan. We've got various manufactured products going along with the SWIP, things like skimmers, underground, post-construction systems, making sure that those manufactured, produced, and provided details don't conflict with the actual installation plan. And that although we may have elements done by others on a site, that those need to still be incorporated by those others, into a SWIP. So a lot of times maybe timing may come into play there, but we need to try and pull those things in you know, if it's geological reports or any other work being done. And then this was just my quick list of more detailed items I've seen that come up from time to time, somewhat frequently. You know, the rainwater, we do not have a standard for straw bale or silt fence check dams, straw wattle, sediment barriers at this point. Skimmer connections are very interesting, and you know, any help to emphasize how those connections are to be made is very much appreciated. In-stream BMPs aren't possible. We see that from time to time. Bypass undetained areas really need to be the undisturbed or minimal pervious areas, and aren't, again, as I alluded to, can't really be compensated for in other areas because of how that water quality volume works. We've got the relatively new equation for redevelopment sites. Definitely, when we're under 2 acres, there's the ability to rationalize those post-construction controls and make sure we're explaining the thought process that's happening there. And lastly, and most probably importantly of the whole thing, is just to contact us, any of us, if you're not sure, rather than moving forward. More than happy to help as much as we can, explain what Ohio EPA expects and or maybe our thoughts and how you might be able to address things. And that's all I have. John?
Yeah, Justin, no, that sounds great. Yeah, I'm going to quickly launch a poll here to see if our attendees want like a quick 5-minute break before Wes takes on. So I'm just launching that poll right now, and it's live. So if you can just respond to that, let us know if you'd like a 5-minute break. Okay, looks like most of them are saying no for a break. So we'll go ahead straight into to Wes's presentation. But I, again, wanted to kind of quickly remind everyone that the Q&A section is always open. So if you have questions, you can post questions to the Q&A. You just hit the Q&A button on the bottom of your screen, and you can type in a question, and our speakers will eventually answer that question. And towards the end of the webinar, we'll have an opportunity where you can raise your hand, and we'll temporarily enable your mic to be able to ask questions as well, if you're unable to you know, ask a question on the question answer board. If you're unable to find it, you can raise your hand towards the end of the webinar, and we'll recognize you that way as well. I got a question that says, will we get a certificate of attendance for continuing for CEUs? Yes, we're going to actually, towards the end of the presentation, have a link that you will need to go in and fill out your name and your email address to which that certificate needs to be sent to, and we'll post that link at the very end in the chat box. I've also temporarily opened up the chat box to discuss any kind of housekeeping things. Like I said, the Q&A questions go in the Q&A box, but I'm going to leave the chat box open for about 5 minutes. So if you have any housekeeping questions, you can direct those housekeeping questions in the chat box for the next 5 minutes or so. But without any further ado, Wes, take over.
All right, thank you very much. Okay. All right. Hopefully everybody can see that. All right. And we'll get started then. So thanks, Justin, for giving us the first half of that presentation on developing an effective and approvable SWIP. And something that I just wanted to add in is that, as Justin ended on, you know, call if you don't understand or need help. Justin and I are here to help you understand the regulations and help you meet them. We didn't always write the regulations or the permit, but we are familiar with it and we can help you understand it and get through it. So the best place for me to start, I think, is a little bit theoretical, like Justin did, with a foundation. So there we go. So just like before you leave your house to go anywhere, you check to make sure that you have all of the essentials. You might pat your pockets or check through your purse to make sure you've got your keys, your wallet, and your phone. For a SWIP, that same procedure can be used to double check your readiness before submitting a notice of intent. Stop and ask yourself, have I calculated the water quality volume? Did I design a post-construction BMP using the rainwater and land development standards? Does my sediment basin, if I'm using one, have a skimmer? Is my long-term operation and maintenance plan put together? Just like if you forget one of the three, it's important that you turn around and go get it. We understand that there's a desire to get your plan out the door, but it doesn't really save anyone any time to send in an incomplete SWIP that doesn't have one of those key parts. It's much better to wait until the SWIP is polished and done and then submit it, because that'll make things go much more smoothly. And as Justin also mentioned, the SWIP represents a detailed thought process. It shows critical thinking and involves site-specific design. A review checks that process, but disorganization can make it difficult. As he said, every firm has a different SWIP template, and that can cause a reviewer a lot of headaches. So it's important to make the important information visible, such as using summary tables or clear organizational patterns, and then a grouping of information. That makes it a lot easier to check that you have everything that you need. The problem can be is that reviews can be a little bit like a word search, as reviewers are hunting and circling important information as they look through your SWIP. And this problem is compounded when a SWIP is incredibly long. Rarely do SWIPs need to be longer than a few hundred pages at most, but sometimes reviewers see submissions that include things like the entirety of the rainwater and land development manual that just by itself is more than 400 pages. But now to get into stuff that Justin brought up and that I'm going to talk about is important issues and common oversights. So after working with reviewers and doing some reviews myself, I've compiled this big list of common issues regarding SWIPs. Some of the topics are pretty important, and I'll take some time to get into the details, while others I'm just going to touch upon. Feel free to note any questions and we can discuss them after. The way I've broken it down is the bolded items are the most important, stuff that I really want to drive home, that we'll have a little bit more in-depth discussion, while the unbolded items are common errors or oversights that are frequently documented in SWIP reviews. And so the following slides hopefully will offer some guidance and highlight ways to avoid these pitfalls and improve your SWIP. So our first important topic is the drawdown requirement. And the drawdown requirement that we have is to ensure that the water quality volume and the sediment-laden runoff in the dewatering volume is properly detained to allow for settling to take place. This settling acts as pre-treatment. The optimal treatment time frame depends on the practice, typically 24 or 48 hours for post-construction practices and 48 hours for active construction basins. Any shorter than the minimum and water will discharge prior to enough time allowing for pollutants or sediments to settle out. Too much longer than that, for example, the sediment basin, the 7-day maximum drawdown, is you're going to have existing volume in the basin displacing and preventing future storms from being detained, and then therefore they won't be treated effectively. A graph is an ideal way to prove that your design meets these requirements. The most common graph we receive is shown here, the HydroCAD print off, and it does not provide enough evidence. Flow rate, that cubic feet per second versus time, doesn't provide the necessary information to check that the water quality volume drawdowns is being met, especially the requirement that states that no more than half of the volume can be drawn down in the first third of that minimum time. Instead, we need to see a graph or a table of some sort that shows the relationship between volume or storage versus time. So like I said, the table on the right does show drawdown, and that would be adequate, but the graph on the bottom, which comes from the water quality compliance spreadsheet, is absolutely perfect. This tool was developed for the OEPA, and we highly encourage you to use it to check compliance prior to submission, and then include it in your SWIP, because it makes this specific review step really easy. As you can see, it checks both the minimum, that 48 hours for this case for the dry basin, and that no more than half is drawing out in that first third of the 16 hours for the dry basin. A smaller topic is the all right, we're good. Is the missing logs. So we often note that logs are missing. Typically, it's the SWIP amendment log and the land disturbance and stabilization activities log. These logs don't have to be terribly complicated. As you can see here, these are just some really simple examples, but they are important, so make sure that you include them within your SWIP. There we go. Our next big important topic is operation and maintenance plan. So improper or incomplete long-term post-construction operation maintenance plans, a little bit of a mouthful there, are one of the most common noted plan deficiencies in reviews. In fact, in reviewing plans for protected watersheds, like the Darby and the Olentangy, just in 2020, more than 50% of initial SWIP submissions are missing a complete operation and maintenance plan. The O&M plan is incredibly important as it ensures that the post-construction BMPs will be maintained and function in the future. When creating your plan, it's important that this plan should be a standalone document, meaning it can be handed off to the responsible party as a small packet and doesn't rely on key information from the SWIP to be understood. Typically, when assembling your SWIP submittal package, we like to see it, or we commonly see it added as an appendix, and that's encouraged and acceptable. So to continue there, as to what should be included within an operation and maintenance plan, you need to first specify the responsible party who will conduct inspections and perform or contract out the maintenance tasks. The inspection process and maintenance tasks must be detailed, as well as the timeline for both. Sometimes an operation maintenance plan or a site requires legal agreements or easements, and the O&M plan should include those if they're applicable. Drawings, details, and explanations are crucial to the continued understanding and proper execution. So, because the party who conducts inspections may be different from the party who performs the maintenance, and both of them may have varying levels of stormwater experience. So maps and directions and explanations are always helpful, maps especially, because it helps prevent trespassing, and so you're going to want to explain to a party how they could access the site and traverse to the BMP without getting into any trouble. And the bottom line really is that the better an O&M plan is, the more likely that the BMP will function properly and fewer headaches will develop for the site occupant and the responsible party in the future. On to inspection checklists. These checklists make sure that important BMPs are in place and being used properly. They make sure that the contractors on site are helping to protect water quality and are following the SWIP. The OEPA has examples, checklists on our website, like the one shown here. And this one actually can be found at the link shown here. And so there should be some narrative that goes along with this inspection checklist that states the inspection should be performed only by qualified personnel and conducted at the frequency specified within the permit, which states up there at the top of that snip in bold. All right, another big topic, the stormwater management report versus the SWIP. What is included in one and what is included in the other? Mainly, the stormwater management report contains post-construction controls and water quality volume, or at least those are the things that we often see in a stormwater management report that need to be in the SWIP. When that kind of information is separated into the stormwater management report, it ends up delaying the review process. When important information is missing from the SWIP, the initial review goes through and notes deficiencies, and a comment letter is sent out, and then we realize, oh, most of that information was contained within the stormwater management report. We'll send that along, and then another review is conducted, and then that can occur in a cycle until all of the issues are corrected. However, if just in the first place that important information in the stormwater management report was duplicated, and that's what we ask, it's up to the consultant to duplicate the important information in the stormwater management report and integrate it into the SWIP. Because again, the SWIP should be a standalone document and doesn't need to reference other documents in order to be understood. Additionally, a stormwater management report often contains sewer pipe calculations or peak flow calculations, which aren't necessarily needed for the SWIP review and can end up making those reviews more difficult by bogging down the SWIP with unnecessary information, at least in terms of the SWIP review. It is important, just not to that review. All right, some smaller topics here with the reverse flow outlets and sediment basin cleanout procedure. Designing BMPs with maintenance in mind is a real win for any site. BMPs are going to function better, they're going to function for longer, and then eventual maintenance will be easier to conduct if the BMP is designed with that in mind. This is especially stressed in basin outlets. Reverse flow pipes, such as what I've got shown here, the angled pipe or the downturned or upturned elbow, draws water from the middle of the column, the water column, in the middle of that micro pool or permanent pool, and it helps prevent clogging. So this is something we really encourage outlet structures to have. Floatables aren't going to be trapped in the orifice, and then bottom settling solids aren't going to be sucked up into the pipe, meaning that that water quality orifice will allow for more impeded flow. On the sediment basin cleanup procedure side, sediment settling basins are primarily designed to let muddy water pool and then the sediments settle out, as per the name. Eventually, it's likely that clean out will need to occur as that sediment storage zone is going to fill up over time. A clear procedure should be included to state when clean out should occur, how are you going to measure when that clean out should occur. Usually a stake is a pretty typical example that marks a certain elevation within the basin. Also, there should be regular basin clean out, whether or not that stake has hit that elevation that's marked in the stake. And then on top of that, the process to remove and dispose of dredge sediments should be included within that maintenance guide. So when it comes to our next big topic of explanations aid understanding, and Justin talked about this a little bit, and how important it is to make the SWIP understandable to everyone who looks at it. And one of the main ways to do that is to include explanations. So if your site is going to use a non-traditional practice of some kind, then it's up to you as the consultant to put together an explanation that shows how that practice is going to be used, how it's going to be implemented, and how it meets the requirements of the permit to protect water quality. So like Justin said, if you have some small or odd areas of a site, like distant corners or sloping sides on the edge of your site, it may seem almost impossible to collect runoff and route it to a basin using a traditional practice. But it's still important to protect it from sediment, from erosion, and a loss of sediment. So it's up to you to come out and figure a way, how can we implement something that will fix this, and that gives you some freedom to be creative and design something that works specifically for your site. Another thing that's important, as Justin mentioned, is that the SWIP is a thought process. And by including explanations, you are demonstrating that you as the engineer are critically thinking about ways that you can protect water quality. And reviewers are always checking to make sure that they can see that. So that the use of explanations are highly encouraged throughout the entire SWIP to help the reviewer and especially the contractor get a better understanding of how the site is supposed to work. However, explanations don't need to only be used for those small or odd areas. They're helpful whenever they can be used. So the example here of an outlet for a sediment basin, and eventually will be a post-construction basin, highlights the important steps to the contractor when implementing the outlet structure. For example, up there in the right, it says skimmer needs an outlet hole to be drilled, and then after construction ends, it needs to be sealed up for post-construction use. Down at the bottom, the water quality outlets need to be capped during active construction, but then they need to be opened for post-construction. Notes like these are very helpful to the contractor, inspector, and reviewer, as they can tell you're critically thinking about your design and working to make everyone, mainly the contractor, as successful as possible. So some other issues, typical individual lot. Justin talked about this a little bit in subdivisions. When you're working in a subdivision, we require a spec sheet that shows a typical individual lot and the associated sediment and erosion controls that are needed to manage erosion and sediment loss. This is a simple addition. It's often overlooked in SWIPs, so be sure to double check that your SWIP has one included when you're working on subdivision developments. If your site is going to be using a regional basin, then it's important that you include the same information that would be required if you were implementing your own basin on your site. That includes the water quality calculations, the impervious area, the total contributing area, drainage maps, and especially a long-term operation and maintenance plan. The reviewer can thus ensure that the regional basin has accounted for your development and will properly function in the future. Another big point that we note a lot in our reviews has to do with boilerplate language. A large portion of every SWIP consists of boilerplate language that is copied from one project to the next, such as standard drawings or spill reporting procedures, for example. And this language periodically needs to be reviewed and updated to meet the newest requirements. So I've put together some of the more common places where boilerplate specs or language needs to be updated. So for example, compost filter socks are an approved alternative to silt fence, kind of what Justin mentioned earlier about straw wattles. It has to be a compost filter sock, and one of the big parts of that is that they're at a 12-inch diameter minimum. And what we typically see is that the diameter specification or the fill material specification is often absent. So that needs to be clarified within your boilerplate specs. For construction entrances in a similar vein, we require that they're a minimum of 70 feet long or 30 feet if you're working on an individual lot within a subdivision. But like we see here, commonly the lengths are specified at 50 feet. So those just need to be updated. Continuing on, if your SWIP doesn't have the most current boilerplate language, you're often going to see common emails like these calling out some of those deficiencies or missing information. For example, inspection reports need to be kept for 3 years after the notice of termination has been approved. And that's easily corrected, adding a simple note. But oftentimes, procedures are not applicable to your site. As Justin mentioned before, you have to prepare the contractor a little bit to give them that toolbox in case plans change. So you're going to want to provide some explanation on maybe hazardous material handling and waste disposal, clean hard fill, equipment fueling, spill reporting, or process wastewater. Can be an opportunity for you to better explain the scope of your project and like Justin said, or give the contractor a toolbox of directions in case plans are amended and the site changes in some way that would invoke the use of these. Drainage maps. They're incredibly important. They show how water and then thus potentially pollutants will navigate your site. Excellent drainage maps like this one here are color-coded, they're labeled, and they display important information about the contributing area, such as total area and the impervious fraction or the impervious area. Now, I will note that you need to make sure to include off-site drainage. Your site doesn't exist within a bubble, and runoff typically ignores property lines. It goes wherever the gradient forces it to. So drainage maps and some of this additional information helps to double check that BMPs are appropriately sized and all your site area has been accounted for and is being treated. Hydrologic soil groups and soil data. What I want to say here is that soil information should be used to support design and is not just a regurgitation of the soil report that's pulled. Did you as the consulting engineer consider soil suitability when designing your site? So for example, if your infiltration basin is located on type D hydrologic soils, then maybe soil suitability wasn't a big enough factor when designing your site because those two don't coexist terribly well. But be aware that pages and pages of soil report information doesn't necessarily show that you've incorporated the report into your design. Again, it's only going to bog down a SWIP. So for example, the SNP I pulled here shows all the important soil information for this site condensed down into a single page. But just last week, I learned of a SWIP review that had 64 pages of soil reports for a 2.5 acre development. It included the entire glossary from the Web Soil Survey. It was comprised of more than 40 pages of definitions, which doesn't really help the reviewer or the contractor. So make sure that when you're making additions to your SWIP, they're adding value and conveying important information, not just adding length. Something that's been brought up a lot recently is with proper skimmer sizing. And that correct skimmer sizing is integral to the proper function of a sediment basin, or else it can drain too quickly or too slowly. But we commonly see that it's miscalculated. In Ohio, skimmer sizing is based on the required dewatering volume, not the provided dewatering volume of the basin. So for small basins, this difference can sometimes be inconsequential, but for enormous basins, the difference can be equally as enormous. So I put together a little example here that highlights why this distinction is so important. So we're going to imagine a 10-acre site, and there's 2 potential designs of a basin that could be used to treat and collect the runoff from this 10-acre site. And just for the sake of the example, no endorsement, but we'll say they're going to use a fair cloth skimmer for this example. So as you can see, the two basin designs both treat the same 10 acres drainage area, which means, as I said, in Ohio, the requirements for dewatering volume is based exclusively on contributing area. However, the volume in Basin B is 3 times the size of the volume in Basin A. And that could be perhaps the second design took into account large peak flow controls for post-construction and planned to make the basin big in the first place instead of expanding a small sediment basin into a large post-construction basin later on. And in Ohio, the requirement is that you provide 1,800 cubic feet per acre of dewatering volume, and that correlates to 0.5 inches of runoff per acre. They're volumetrically equivalent. So for a 10-acre drainage area, as the one in the example, that would be 1,800 cubic feet times 10 acres, or 18,000 cubic feet of dewatering volume are required for each of those basin designs. And that happens to exactly equal the provided dewatering volume in Basin A. So in an event that would produce a ½ inch of runoff, it will fill the dewatering volume completely. And if you go through with the Faircloth skimmer sizing, you would come out with a 3-inch skimmer that has a 2.9-inch orifice plate. And that would result in that volume draining in exactly 2 days. Now, the same event would only fill a third of the dewatering volume in Basin B, as it provides 54,000 cubic feet. And so if you mistakenly sized your skimmer based on the provided, at 54,000 cubic feet, you would think that you would need a 5-inch skimmer with a 4.6-inch orifice plate. And what will end up happening is that your dewatering volume will draw down in significantly less than 24 hours, which is going to result in a violation of the CGP. So you can see why proper sizing is so important. Now, Justin and I do acknowledge that some skimmer manufacturer guidance that exists out there does not currently describe this procedure very clearly. So we're actively working to improve that and make it easier for everyone to understand. And the last note that I want to say on this topic is that it's important that the contractor implements the correct skimmer type with the correct orifice size that's specified within the SWIP. And it's way too common for contractors to use a skimmer that they had left over from a previous project instead of the exact make and model that was detailed in the SWIP for this new site. And a suggested method that we've heard has success in the past is that the consulting engineer requests the contractor supply a picture and a shop drawing of the skimmer that they're going to use on the site back to that design engineer for review and approval. That's a good way to double check that things are being done properly. So we're getting towards the end here a little bit. Concrete washout areas, as you can see in these two side-by-side pictures, which actually are from the same site, which is kind of funny. They're not all created equal. And they often, in concrete washout areas themselves, pose a challenge in a SWIP sometimes. What's important that your SWIP notes is that the concrete washout areas are lined, watertight liner, and they're properly marked with signage, because if on-site staff can't easily locate the concrete washout area, then they're probably not going to use it. And then being watertight is important because the pH of that wash water can negatively impact nearby waterways, which is why it makes it so important where the area or the designated area for these washout areas are. They need to be located away from catch basins, drains, or on-site or nearby waterways. However, that leads me to the most common response that we hear from designers, that they don't want to designate a specific area because perhaps the contractor knows a better location that'll be more convenient. So they said, well, the contractor will decide where the concrete wash water, the concrete washout area is going to be. But that brings me back to the fact that the location is important to protecting water quality. So it's better to designate a safe location or a couple safe locations that the contractor can choose from than to completely leave it up to the contractor. It just helps reinforce some of those good practices. And then also remembering that the SWIP is a living, breathing, and amendable document. So things can change if they need to. So if the original location of the concrete washout area doesn't really work, then that can be amended and you solve the problem. The last topic here has to do with land use and site maps. Site maps and existing land use explanations, back to that explanations again, are a great way to help new eyes understand your site when looking at the plan. And they're especially important when dealing with large or multi-phase projects. You know, you look at some of these enormous subdivision projects and you're on like phase 7 of 12 and you're like, which area is currently being developed? Which basins already exist? Has this area already been cleared and graded? If not, so those explanations are really helpful, and satellite or aerial pictures can help there. So don't be afraid to combine this land use and site map to save space and show that the requirements are being met and provide a little bit of clarity. And that kind of wraps up my portion of the presentation. Thank you very much for attending. We've got some time here for questions. We hope you learned a lot about developing an effective and approvable SWIP. And we can go back to previous slides. We can make the presentation available if that's something that you desire. And we got our contact information there at the bottom again. Great.
All right, thank you, Wes. Appreciate it. I know some of you have posted questions already in the Q&A section, and I think Justin has answered most of the questions as Wes was giving the presentation, and you're welcome to look at those answers. And it looks like Justin or Wes, we've got a series of questions from one of the attendees. I didn't know if you wanted to kind of address that. And in the meantime, if the attendees would like to be recognized for a question, right now you can raise your hand. You should have a little button that allows you to raise hands, or if you'd rather not speak over the recording, you can just post your questions to the Q&A section, and Justin and Wes will try to respond to their best of their ability. Here around 2:30, in your chat box will become available the link to request the PDHs. So at any time at that point, you can just hop on there and just put in a request for the PDHs, and Sarah and I will try to get that to you in a timely manner. But in the meantime, I'm going to turn it over back to Justin and Wes to address some of these questions that are coming in the Q&A box. And while they're addressing those questions, if anyone has any questions that they would like to ask vocally, you may raise your hands and I'll try to recognize you best as possible.
Okay, thanks, John. I'm sorting through these few questions that came in. We can try and fire off some answers here quickly, and others always feel free to call or email Wesley or I with them if we don't get complete answers here to you now. But inspection logs, do they need to be part of the SWIP, or can it be a separate sheet kept on site? The answer is yes, they're part of the SWIP. That's where the SWIP is so weird. It is a document that you're sending in that is multiple tools, including drawings, narrative, forms, that then becomes an action item on site that includes those logs and forms that the contractor then maintains. So the answer to that quickly is yes. And Wesley, just chime in if I'm misspeak or
You've got it
you
covered.
have a better answer. Question 2, does the long-term maintenance plan have to be a separate document if the BMP is maintained by the County Drainage Maintenance District? I mean, yes, it's generally they're a separate document. Now, maybe that's semantics. Maybe it's just part of this overall SWIP that gets pulled out. But you know, I understand the point there is they don't necessarily need something separate because they have all of the information with the county. But the short answer, I guess, is per the permit would be yes. Does water quality have to be addressed for a portion of the site that can't be directed to the basin due to grade? It's located within an observed buffer, will be grass covered. So that, you know, that's sort of this is a challenging question to answer. I mean, technically the answer is the entire site needs to be covered and treated. But you know, there's a certain amount of reasonableness that we understand as you're indicating in the question that there are areas that just are not possible to collect. And you know, if it's complicated, again, call us. And those areas that are generally grass, small areas that tend to be the backside of embankments, similar to the drawing I showed in the presentation, that you know, just really not feasible to treat. I mean, those I think when they're grass, I kind of like to term them as almost self-treating. Not to say they're not treated. They're just sort of self-treating areas. So the answer to that is a little convoluted, and call me if you have questions, but those are, you know, that hopefully was somewhat of an answer. Question 4, if the site is considered to be the site considered to be a violation if the skimmer is properly sized, functioning properly, but there's no inlet protection on curb or surface inlets? And that's a common discussion point for us now. And I'm gonna play the card on that, unfortunately, that in the engineering standpoint, I'm gonna have to defer to give you a better answer to our regulator opinions and the rest of our staff. But ultimately, I mean, in my opinion, having the curb inlet protections, whether they're bags or dandy bags or something else, is part of the treatment train that helps protect the sewer system if in the event that it's not going to be, you know, cleaned out at some point, which some communities do require, and also to help continue the train of treatment that amplifies what the sediment basin is doing. But I understand that at a certain point, those inlets become sort of problematic, especially as residential subdivisions reach the end of the build out. So I think I would say consult with the plan for it, yes, but you know, when push comes to shove, consult with the local regulators. Looking for a response to concrete washout argument by many contractors. Why wouldn't this be in the gravel driveway area that will be paved over with concrete? What's the difference between placing concrete on the ground versus washing out in the gravel area without a barrier? I was looking at Wes. I thought for sure he was going to chime in since he talked a lot about construction.
Yeah, so the issue, so I understand that idea that, well, if you're laying concrete, why can't you just wash out concrete onto the ground? They're both getting into the ground, and a lot of it has to do with the ability for the pollutants to mobilize. So when you're washing out the concrete, you're adding a lot of water to that system and giving it an opportunity to mobilize, spread, infiltrate, and get into the waterways. And it's all about minimizing the impact. And so we acknowledge that there will be impact, but you're trying to do your best to minimize impact.
And I think that, yeah, in those, there may be cases, there's always times we're going to do things that aren't going to be a problem, but that's relying on everyone understanding on their own terms what is and isn't a problem. So that's sort of where the SWIP becomes providing a toolbox for making sure that concrete waste washout or whatever disposal isn't the problem. And that whole ensuring discussion I sort of started with. Okay. this is kind of a running tab, and it pushes the oldest questions to the bottom. So I'm going to try and keep up in order. Any feedback or pushback regarding individual lot controls and compliance with such in allotments? I know the center that I can get in communication with. I'm not certain exactly what the question is there. Specifically. Okay, I'm going to continue up to the next one. There seems to be a lot of detailed information contained in the SWIP, such as text, color, drainage maps, logs, calculations, O&M. Yeah, that's true. But sort of the oddity of the animal of a SWIP. Are you hearing from consultant regarding how many hours it takes to create a SWIP? That's a good question. A question I have, and I think it probably varies drastically depending upon A, like I mentioned, the type of project. Some are small, some are big. B, the level of effort being put forth to address those things, and how often that work is being done, and how much of that can be done in boilerplate standards, etc. So I don't have an idea. I've never heard issues regarding the time it takes to complete or costs to having a SWIP. As far as that being problematic before, but if it is, there's, you know, we're always interested in hearing feedback on how things can be improved there. Okay, where am I next? A lot of individual lot site plans and subdivisions have the wording proposed silt fence. Why is the wording proposed and not required or something similar to that? Struggle with getting builders to install controls in the back of their lots. And yeah, on that, you know, boy, that's a whole, there's so many topics we could spend hours on probably, and proposed is in engineers terms is often always used to dictate what's new versus what's existing and clarify that. And often there's other ways of indicating if something is optional or there's alternatives to it. So I think semantics, I don't want that to get in the way. You know, if there's something better that can be done along those lines, we should probably be doing it. I can see where the confusion comes in. That proposed sort of indicates like we think this, but you may think otherwise sort of scenario. But this is where the entire SWIP being built together really shows the definitiveness.
Preference on which one we want to do next, Justin?
I apologize. Yeah, my screen just went completely blank, so I don't know if that's on my end or someone else's end, but Wes, if you want to continue on while I figure out maybe what's going on here.
All right. Well, we'll go up to the top, the oldest of the questions. We have a question here that says, where do we direct a contractor that has never put together a SWIP before? And that's an excellent question. Currently, we would direct them to, there's the US EPA has a great big toolbox of guidance on putting together a SWIP. Now you can direct a contractor to this presentation if you'd like in the future. And then we'd also suggest that the contractor reach out and talk to some district staff, such as our various district staff or local soil and water staff, because that can kind of help talking through this process. The implementation of the SWIP is great to talk about it with someone if you're unfamiliar. It's a great way to learn. You think of any other references, Justin, that we might want to direct contractors to if they've never put together a SWIP before?
Thank you. I'm back here. I'm not sure what happened there. A little unnerving, but as far as references goes, yes, I think that's something that you know, there's a lot of older guidance, various places out there. Maybe that's something we can look to add to the website at some point. I know US EPA has a lot of very generic type things, but I don't know we have anything specific Ohio-wise that we could do. But maybe that's something we can add in the future to the rainwater manual.
Great. Okay. So the next one, we've got sediment barriers / logs are not recommended for ditches. Exactly. Suggestions for government ditching projects that drain to a stream for sediment management and work within the right-of-way. Combination barriers have been used, but are not accepted or not within the rainwater and land development manual. Yeah, Justin touched on this. Really the tried and true practice there is the rock check dam. The barriers or silt fence or straw bales aren't designed with that in mind. And so you're kind of using a practice that is explicitly stated not to have concentrated flow and then putting it in the area of concentrated flow. So I think we would probably look back at rock check dams, but you can, as you might bring up, the ditching projects, the intent is not to impede drainage. So that's where we would emphasize how important it is to rapidly stabilize banks within those ditching projects. Right. You have anything to add, Justin?
No, I think that you know there's some good points there. It's those type of questions sometimes are struggle because again it leads to that you're sort of on your own, deviating outside the rainwater. There's the manual. There's probably some combination barriers. I don't know that may work, that may not, and yeah, that's kind of those are things that we're going to have to work to continue to address to see if we need to build better specifications on.
So I think this next one here references what was discussed earlier with the concrete washout. So what if there isn't a waterway nearby or the temporary driveway is cut down into the grade and filled with stone, so the wash water won't leave? And I guess we get back to unless you're lining the driveway and preventing infiltration, then it does leave. It is going to leave somewhere. And that's why it's so important that we say the washout areas are lined, usually with like a plastic liner. They could be those self-contained like metal bins, those units. So I see what you're getting at, but again, that's what we're trying to prevent is any potential for impairment.
It's an interesting thought. I mean, maybe that's something that could be connected into a practice in some way, shape, or form at some point. Somehow.
Yeah. All right. So it looks like these two might pair together. Any feedback or pushback regarding individual lot controls and compliance with such an allotment? Regarding individual lot controls, they're often in the SWIP, but not always implemented to compliance standard. How do other soil and water conservation districts enforce this very important part of construction? Don't know, maybe John, do you want to talk about this at all? Asking other soil and water conservation districts how the enforcement works there.
Wes, thank you. I'm going to have to punt on that one. I'm actually going to put Che Alberto, who oversees our MCM program for pre-construction. Che, I've enabled your microphone. If you could jump in and kind of talk about it a little bit, I'd appreciate it.
John, we kind of follow the MS4 permit so that we regulate these individual lots. They're part of the larger common plan. So we inspect them, we review their plot plans, and we do enforce them. And the mechanism that we have is, we use the building permit, approval process, when we're part of the approvals for the building permits before it's issued. And we're also part of the building permit process before the occupancy is issued. So that way, that's how we kind of like get a handle on it. But yeah, in terms of like the MS4 permit, we are inspecting these individual lots as required by the permit. I hope that answers your question.
Thank you, Che. Matthew, I hope that answers your question. If you need more clarification, feel free to reach out to Che or I, and we're happy to help for sure.
Great. Convert to that one. All right. Justin, does the SWIP need to have all the drainage maps and calculations that are in the drainage report? It sounds like the drainage report would need to be part of the SWIP.
Yeah, that's a good question, and that ties into a little bit about what Wes you got into in a couple of detailed comments, and I also sort of alluded to that. The SWIP is really it's its own entity. I mean, it's a separate standalone plan per the permit, and a lot of times there is a lot of overlap to the drainage report, as they're both, at least on the post-construction side, that's the problem. They're both connecting the same information as far as the calculations and design of the drainage system. So, which includes the post-construction water quality controls. And oftentimes those are going to the same entity for review, county engineer, city engineer, or whichever stormwater district, whichever department does those reviews. So at times they kind of become one and the same in a weird sort of way, but they're not. They're different, really different documents, different animals. There's very little of the drainage report. It needs to be really in the SWIP, just some of those water quality relevant calculations. So my advice would be yes, to maintain those as separate documents, unless you're hearing otherwise.
Yep, that would be a great opportunity, as I think we talked about, Justin, duplicating some of that important information and including it within the SWIP, but the entire document doesn't need to be included. Great. All right, up here at the top, is it okay to use the skimmer sized for the required volume when presented with a basin that is provided volume larger than the required? That's exactly the correct thing to do. Skimmer sizing should be based on the required dewatering volume, not provided dewatering volume. So if the provided dewatering volume is significantly larger than the required, that's where we would see issues, and that's why it's all based on required volume. Great. Getting here to the end there. Justin, does a home builder need to have individual lot BMPs if there's a skimmer on the basin outlet?
Well, the skimmer needs to be as part of sediment basin, and the basin needs to be effective throughout while construction is active. So for most sites, that's kind of cut and dry. But yes, with the residential scenarios, you often reach this gray area, which when do individual lot controls take kind of primary function over the rest of over the whole site. If everything else, like I mentioned too, was done up front properly and was stabilized, all the reserve areas and drainage areas and roads are paved and all of that. And a lot of these are really good questions and questions that we get in our get a little bit beyond the technical elements that I'm more used to dealing with. So I hate to give a specific answer and have you quote me on it, but I think that there's an area, and we've kind of recognized that. But here's our problem: is once you write that down, it's written down, it's a number, and it's problematic to do. There is probably some sensible point at which a large site has fairly insignificant pollution potential, and individual lots are now able to act as a primary control. So I don't know when that occurs though, and I don't know if we've ever really stated or can state when that happens. So that's probably not much of an answer.
That's okay. That happens. All right, and the last open question that we have references back to one of our earlier discussions about proposed silt fence. And this is a great suggestion. Instead of referring to it as proposed silt fence, refer to it as construct abbreviated silt fence. That would be a really simple solution to that. So hopefully that would work. And that answers all of our questions. So I'm going to stop sharing.
All right. Thank you, Wes and Justin. Just want to kind of throw it out there. I know we're kind of 22 minutes past our original timeline, but looks like we have had a few of the folks drop off, and that's understandable. But looks like there's no questions, there's no raised hands, so we don't have to recognize anybody. And I think we've exhausted the questions on the Q&A section. We'll try, theoretically, this has been recording through the entire process, so hopefully technology cooperates here, and we can upload this video to YouTube, and we'll send you the link so that you can view this video in the future again for reference. And Justin and Wes, I think, have talked about potentially making parts of the presentation available, in which case we'll send that in the email as well. As part of a follow-up email that we're going to send, we'll also ask you to send us your feedback. Like we mentioned before, we're not used to doing webinars. We are very much in-person presenters, so it'll be great to hear your feedback on what we could improve next time if we have to continue to do webinars, and so that feedback will certainly be very helpful. With that, we'll go ahead and we will conclude this webinar at this time. Wes, Justin, any parting remarks here?
Thank you for attending.
All right.
Thank you very much for the opportunity, and feel free to contact us with questions. I know some of those were there's a lot to get into this discussion, and we hopefully helped out with at least a little bit.
All right. Thank you so much, everyone. Take care.